Withering process in tea manufacturing. Overview and key point. Introduction to withering. A critical process in CTC tea manufacturing. Involves reducing moisture content in tea leaves. Prepares leaves for subsequent stages of production. Enhances leaf pliability for rolling and cutting. Affects the final quality and flavor of the tea. Objectives of withering. Reduce moisture in the leaf to save drying energy. Physically soften the leaf for easy handling. Promote biochemical changes in the leaf. Achieve optimal leaf condition for rolling. Maintain the quality of the tea during processing. Process of withering. Airflow is used to remove moisture from leaves, typically performed on large troughs in tea factories. Hot air is added when the humidity is high. The process can take 6 to 12 hours depending on conditions. Even withering is important for tea consistency. Physical and biochemical conditioning. Moisture loss prepares leaves for further processing. Softens the cell walls, making the leaves more flexible. Initiates biochemical reactions essential for flavor. Reduces leaf brittleness to avoid breakage. Improves fermentation by promoting enzyme activity. Trough withering in South India. Common method for withering in South Indian tea factories. Troughs range in size from 60 to 120 feet in length. Newer, wider troughs with dual fans are used for efficiency. Allows for even distribution of airflow for uniform withering. Electric fans help reduce energy consumption during the process. Standard trough dimensions. Conventional width of 6 feet and length of 60 to 120 feet. Modern troughs have widths between 12 and 15 feet. Wider troughs improve even withering across the leaves. Leaf loading is around 30 kilograms per square meter. Troughs are designed to optimize airflow and energy use. Energy conservation in withering. Switch off one fan after the initial stage of withering. Ensure adequate airflow to avoid leaf overheating. Use lower fan speeds to save power when possible. Incorporate reversible fans to reduce energy waste. Efficient fan operation reduces overall factory energy consumption. Air requirements for withering. Airflow helps transport moisture away from the leaf bed. Requires a constant flow of air for proper withering. Around 2,000 tons of air needed per ton of tea. Hot air can be used during humid conditions. Correct air temperature and humidity are critical. Reversible airflow systems. Helps achieve even withering by reversing airflow. Can avoid turning leaves manually during the process. Reduces energy consumption compared to traditional fans. Challenges include air heating and mixed results. Reversible systems require efficient airflow design. Fan efficiency in withering. Fans must operate at optimal speeds for efficiency. Doubling fan speed can increase power usage by 8 times. Reversible fans reduce airflow by up to 30%. Properly designed fans improve energy efficiency. Consistent air pressure across the trough is essential. Enclosed troughs for better withering. Fully enclosed troughs prevent air from escaping. Movable baffle plates adjust the direction of airflow. Allows for uniform withering without turning the leaves. Prevents the need for reversible fans. Air heating systems improve moisture removal. Plenum chamber and air pressure. Ensures even air distribution across the trough. Must maintain consistent pressure throughout the trough. Tapered designs help balance air pressure. Reduces inconsistencies in withering. Avoids leaf damage from uneven airflow. Methods to heat air in withering. Direct use of hot air from the dryer. Hot air ducting systems with damper control. In situ radiators using steam or hot water. Exhaust air mixed with ambient air for reheating. Controls must ensure proper moisture removal without overheating. Challenges in wet season. Excess surface moisture on leaves during wet periods. More bacteria can grow, affecting tea quality. Requires warm air to remove surface moisture. Difficult to achieve, even withering under high humidity. Wet leaves need more care to prevent dull infusion. Optimal temperature for safe withering. Best to use air temperatures between 80 to 85 degrees Fahrenheit. Surface evaporation cools the leaves during early stages. Avoid hot air during later stages to prevent burning. Proper temperature control leads to higher tea quality. High temperatures reduce flavor, but increase color. Moisture content and withering. Ideal moisture content is 70 to 72% after withering. High variability in green leaf moisture can complicate withering. Leaves with less moisture tend to be more brittle. Consistency in moisture levels helps maintain tea quality. Monitoring moisture ensures optimal processing results. Expressing the degree of wither, traditionally expressed as the ratio of withered leaf to green leaf. Moisture content in leaves varies with weather and leaf type. Percentages can be misleading without considering moisture levels. Better expressed in terms of moisture percentage of withered leaf. Ideal moisture content should be 70 to 72%. Impact of withering on tea quality. Longer withering times lead to stronger color and flavor. Shorter times favor better briskness and flavor. Poor withering can result in flaky brown leaves. Quality can diminish if leaves are not properly conditioned. Chemical changes during withering influence final taste. Monitoring air temperature and moisture. Wet and dry bulb thermometers are essential tools. Moisture content testers help in determining leaf conditions. Daily weighing of leaves ensures proper water loss. Ambient air temperature should be monitored closely. Plenum chamber temperatures are critical to control. Instruments for withering process. Thermocouples and digital hygrometers help optimize conditions. Multi-channel recorders track air and leaf temperatures. Moisture meters are crucial for determining leaf dryness. Automation tools improve the consistency of withering. Load cell-based systems monitor continuous withering. Conclusion: withering is a crucial step in tea manufacturing, impacting the final product quality. Proper moisture control and airflow are essential for uniform withering. Modern methods and equipment, like reversible fans and enclosed troughs, improve efficiency. Attention to temperature and moisture levels helps preserve flavor and texture in the final tea. Monitoring and adjusting the process ensures the best quality tea is produced.